Hi everyone. Today the topic is property changes of mixing. So to know about the property changes of mixing, first we consider the excess property equation, that is Me equal to M minus MID. So these equations we have studied in the previous chapter. So the summability relation for an ideal solution is MID equal to sigma I xi Mi bar ID. So by using these two equations, we will find the property changes of mixing. So by using these equations, we write the expressions for different properties, that is G, S, V and H. So GE, that is the excess Gibbs energy expression, is written as GE is equal to G minus sigma I xi Gi minus RT sigma I xi ln xi. Similarly, excess entropy SE equal to S minus sigma I xi Si plus R sigma I xi ln xi. Similarly, excess volume is equal to V minus sigma I xi Vi. Excess enthalpy equal to H minus sigma I xi Ha. So in the above equations, the right side is expressed as M minus sigma I xi Mi. So this quantity is called property change of mixing. So we simplify this equation. So G minus, we consider all the terms as sigma xi Gi. So we take that as property change of mixing, and that property change of mixing is represented by the symbol delta M. So by definition, we can write delta M is equal to M minus sigma I xi Mi. So here M is molar property of a solution. So M can be any property. So from this we can write the above equations. So here Mi is molar property of pure species, all at the same temperature and pressure. So considering this, we write all the above equations as Ge is equal to delta G minus RT sigma I xi ln xi, Se equal to delta S plus R sigma I xi ln xi. Similarly, Ve is equal to delta V, He is equal to delta H. So here we are just simplifying the terms from the above equations. So here we are writing G minus sigma xi Gi as delta G, S minus sigma xi Si as delta S, and V minus sigma xi Vi as delta V, H minus sigma xi Hi as delta H. So by writing these expressions, we get delta G, delta S, delta V and delta H. So all these terms are Gibbs energy change of mixing, delta S is entropy change of mixing, delta V is volume change of mixing, and delta H is enthalpy change of mixing. So now we consider an ideal solution. If you take an ideal solution, each excess property is 0. So and for this, the above equations become delta ZID is equal to RT sigma I xi ln xi. Similarly, delta SID is minus R sigma I xi ln xi. So entropy and Gibbs energy for ideal solution. Similarly, delta VID is equal to 0 and delta HID is equal to 0 for ideal solution. So since GE, SE and VE, HE becomes 0, we get these equations. So the above equations will show that excess properties and property changes of mixing can be calculated from one another. So here the property changes of mixing delta V and delta H are identical to the corresponding excess properties. So from these equations we can calculate delta G, delta S, delta V and delta H for an ideal solution simply in a simple form. Next we take the experimental mixing process. So how the mixing process takes place. So for a mixing process, how we can write the expressions for the mixing process. For that we consider this diagram of experimental mixing process. So here this experimental mixing process is taken for a binary system which is represented here. So here we are taking two species 1 and 2 and then they are combined in the second diagram. So here the two pure species are initially separated by a partition. Then after withdrawal of partition, the mixing takes place. So as mixing takes place, expansion or contraction of the system is accompanied by movement of the piston. So here you can observe, so the piston has been moved from the point here, so that distance of the piston is represented by D. So after withdrawal of partition, the mixing happens. So that mixing is represented by expansion or contraction of the system, which is done by the movement of the piston. So here pressure is constant and also heat is added or extracted to maintain the constant temperature. So here when mixing is done, the total volume change of the system is delta V power T is equal to N1 plus N2 into V minus N1 V1 minus N2 V2. That is the total species into volume minus the individual species. So here, since this process occurs at constant pressure, the total heat transfer Q becomes equal to total enthalpy change of the system. So Q is equal to delta H power T, which is equal to N1 plus N2 into H minus N1 H1 minus N2 H2. So these two equations we divide by N1 plus N2, the total number of moles. So delta V becomes equal to V minus X1 V1 minus X2 V2, which is equal to delta V power T by N1 plus N2. That is the total volume by N1 plus N2. Similarly, delta H is equal to H minus X1 H1 minus X2 H2, which is equal to Q by N1 plus N2. So here delta H becomes equal to Q by N1 plus N2. So here the volume change of mixing delta V and enthalpy change of mixing delta H, they are found from the measured quantities, that is the total volume and Q. So delta V power T and Q. So here since Q and delta H both are associated, this delta H is usually called as heat of mixing. So from these expressions we can find the heat of mixing, that is delta H. So in this way we can calculate the values for the experimental mixing process. So if you take different species, so pure species 1 and 2, so you can take any system, from that we can calculate the mixing volume and delta H by using these expressions. So these are the property changes of mixing. So this is the today's topic. So if you like my video, please subscribe my channel. Please share my videos. Please like and comment my videos and channel. Thank you so much.